This question is given in GATE 2013. You could read the question there. I have just summarized it this way. See, they are saying that there is a memory location X whose value is initialized to 0. And then they are saying that there are 4 processes W, X, Y and Z. And in these 4, out of these 4, W and X, they are trying to increment the value of X by 1. And Y and Z, they are trying to decrement the value of X by 2. Alright. And for the synchronization, they are using a semaphore S. Right. So in case if this semaphore would have been a mutex, which means binary semaphore, then all these operations, whatever order they get executed, the final answer of the X will be, see this, 2 times we are incrementing and 2 times we are decrementing, and when we decrement it, it is decremented by -2, right, 2 times, right. Therefore, if all these instructions are going to be executed in any order, the final answer has to be -2, isn't it? By 0, see this. Initially the value is 0, then +1, +1, -2, -2. Any order you perform these 4 operations, it is going to be -2, right? In case if it is a mutex. But then they are saying that S is a counting semaphore. Counting semaphore means, you know that, right? So counting semaphore means we know more than one process can enter the critical section at the same time, which means they are initializing the counting semaphore value to 2. Therefore, at any time, 2 processes can simultaneously access the value of X. Then the question is, if this is the scenario, which means they are saying that at any time 2 processes can access the critical section, then what will be the maximum value of this X possible, this memory location X possible? That is what they are asking. Maybe watch it, I'll just explain you. So one thing you should observe is X equal to X plus 1, even though I am writing it as one statement, it contains 3 parts. One is load the value of X, and second is increment it, and third is store, right? There are 3 instructions at the machine level, and preemption can occur at after any of these instructions. And similarly here also, when X equal to X minus 2, it contains 3 instructions at the machine level. One is load the value of X, and 2 is decrease the value of X, and 3 is store the value of X, right? Therefore preemption can occur at any of these statements. And if you don't want any preemption, then you should actually use, yes, preemption can occur. If you want the consistent results, you should have used the mutexes. But then instead of mutexes, you are using the counting semaphore, because of which there will be a problem. Let's see what the problem is. Okay. Now assume that. So you can think of this as 3 lines. One is load X, other is increment X, and the other one is store X, right? So assume that initially the value is 0, and initially W has run, and let us say this is line number 1, and then all the lines, let us say W has run to completion, which means W has executed all these 3, P of S, and then X equal to X plus 1, and then B of S, right? So after this is done, what will be the value of X? So the value of X after W is done with it is 1, right? And then assume that, and W has come out, therefore value of S is still 2. I think you know how the values of S will work. Whenever any process tries to perform a down, its value will be decremented by 1, and whenever it performs up, its value will be incremented by 1. Initially W entered it, which means it decremented and incremented, therefore the value of S is still 2. Now at this point, X has entered this, right, and then P of S is performed successfully, and then it has loaded the value of X. Now what is the value of X that X has loaded? In its register 1. Therefore in the register of X, it has loaded 1, and at this point it got preempted, which means it didn't go further. It has just seen the value of X and it got preempted, right? And now what will be the value of S? Since X is already inside the critical section, X is already inside this here, the value of S is still 1. The reason is S was initially 2 and X has decreased it by 1, therefore its value will still be 1. Therefore one more process can enter. Now assume that at this point Y has entered, right? Y has entered, and now see, why am I trying to do this is I am trying to show you what is the maximum possible answer that could be possible. Now Y has entered it, and let us say Y has run till completion, which means Y has performed the down and made S as 0, and then Y has decremented the value of X. So what is the value of X? X is still 1. The reason is oh, I have been using process name as x and integer also as x. Let us say it is capital X, process is capital X. Okay, now watch it. Now capital X has read the value of x into its register, but it did not write it back. Therefore the value of the memory location x will still be 1, which was initially incremented by w, right? And therefore y is going to see 1, and then it is going to make -2, which is nothing but -1 now, and this value will be stored in x. So after y has finished, what will be the value of x? It will be -1. And now y has finished and it came out. So by the time when while y was entering, the s value was 1 and it decremented to 0, and while it is leaving, it will increment 0 to 1. Therefore again the semaphore value is 1, therefore z can enter now. Now z is trying to finish its execution. Then what happens when z has entered, right? It will see that the value of semaphore is -1, and now it will try to decrement it by 2, and therefore finally it will write the value as -3. Therefore by the time z has exited, the value of this x will be -3. Got it? The value of x is -3. Now at this point, if x tries to run again, then what happens? X will see that it's earlier when it loaded the value of x, that will be 1, that was 1. Therefore it will not again watch the value of x. Whatever was there in its memory, it will continue with that value, right? So what is the task of x? It is going to increment it by 1. Therefore it is going to increment it by 1, and now the value is 2, and finally this value will be written into the memory at the end. Therefore by the time x has completed its execution, the value of small x in the memory will be 2. Therefore the maximum value possible is 2. It is not the correct value, but it is possible. So how did this happen? One process has incremented the value from 0 to 1, and the other process has loaded that value and didn't update it yet, and the remaining two processes have come and they have updated them and stored them, and they left as it is, and later the one which has loaded 1 in its memory, that in its register, is now using the old value, not the present value. It is called race condition. In case if this would have happened first and then this one and this one, then the values would have been really different. Got it? Then we would have got -2. So depending on the execution of the this one, we might get many values, but the highest value possible is 2. Anyway, you cannot get more than 2, isn't it? Why? Initially the value is 0, right? And there are only two processes which are performing +1 and +1. Therefore in best case you could get only 2. More than 2 it is never possible, right? And I have shown you a sequence in which 2 is possible. Therefore 2 is the answer. 3, 4, 5, nothing is possible. Either it will be 2 or less than 2, right? Then what will be the minimum value possible? What is the least value possible? -4, isn't it? Can you guess how it is possible? See, if you want to look at the least value, then maybe initially you send y, and then it will make from 0 -2 to -2, which means the value of x will be -2, and then you send z, but then don't run it till completion. Just run it for the part where it loads the value of -2 and store it in its register, which means in its register it is containing a value of -2, right? And then you wait, and then you send w and x completely to execute. Then what will they read? They will read -2 and keep on incrementing it. This one will read -2 and increment it by 1. Therefore this one will become -1, x will become -1, and this one will again increment it, which means it will become 0, and they will go out. And finally when you again run z, then what happens is z is going to see -2 from its register, and again it is going to decrement it by -2. Therefore -4 is the least value possible. So least value possible because of this will be -4, and highest value will be 2. Anyway in gate they have asked highest value, and you can find out some sequences which will give you different values also. Anything between 2 and -4 is also possible. The reason is you are allowing two processes to enter into the critical section at the same time. If you want a consistent answer, single answer, just allow one process, which means you should have used initialized s value to 1. If you initialize s value to 1, then what will s be? Mutex. Then it will be completely atomic operations, right? I mean, there will be no race conditions at all if you do that, right? Anyway, this is asked in GATE 2013. You please read the question and answer it. Thank you.